In road transport terminology, a lane departure warning system is a mechanism designed to warn the driver when the vehicle begins to move out of its lane, unless a turn signal is on in that direction. On freeways and arterial roads, these systems are designed to minimize accidents by addressing the main causes of collisions: driver error, distractions and drowsiness. In 2009, the U.S. National Highway Traffic Safety Administration, NHTSA, began studying whether to mandate lane departure warning systems and frontal collision warning systems on automobiles. Types. There are three main types of systems. Systems which warn the driver. Lane departure warning, LDW, if the vehicle is leaving its lane. Visual, audible, and/or vibration warnings, systems which warn the driver and, if no action is taken, automatically take steps to ensure the vehicle stays in its lane. Lane keeping system, LKS, reactive and proactive. The first production lane departure warning system in Europe was developed by the United States company Iterus for Mercedes Actros commercial trucks. The system debuted in 2000, and is now available on most trucks sold in Europe. In 2002, the Iterus system became available on Freightliner trucks and North American vehicles. In both these systems, the driver is warned of unintentional lane departures by an audible rumble strip sound generated on the side of the vehicle drifting out of the lane. No warnings are generated if, before crossing the lane, an active turn signal is given by the driver. Sensor types. Lane warning keeping systems are based on video sensors in the visual domain, mounted behind the windshield, typically integrated beside the rear mirror. Laser sensors, mounted on the front of the vehicle. Infrared sensors, mounted either behind the windshield or under the vehicle. Working principle. Lane detection system used behind the lane departure warning system uses the principle of Huth. Transform uncanny edge detector to detect lane lines from real-time camera image fed from the front-end camera of the automobile. A basic flowchart of how a lane detection algorithm works to help lane departure warning has been attached on the right side. Timeline of available systems. 2001. Nissan Motors began offering a lane-keeping support system on the SEMA sold in Japan. 2002. Toyota introduced its lane monitoring system on models such as the Caldina and Alphard sold in Japan. This system warns the driver if it appears the vehicle is beginning to drift out of its lane. 2003. Honda launched its Lane Keep Assist system, LKAS, on the Inspire. It provides up to 80% of steering torque to keep the car in its lane on the highway. It is also designed to make highway driving less cumbersome by minimizing the driver's steering input. A camera, mounted at the top of the windshield just above the rearview mirror, scans the road ahead in a 40-degree radius, picking up the dotted white lines used to divide lane boundaries on the highway. The computer recognizes that the driver is locked into a particular lane, monitors how sharp a curve is, and uses factors such as yaw and vehicle speed to calculate the steering input required. 2004. In 2004, the first passenger vehicle system available in North America was jointly developed by Iterus and Valia for Nissan on the Infiniti FX and, in 2005, BM vehicles. In this system, a camera, mounted in the overhead console above the mirror, monitors the lane markings on a roadway. A warning tone is triggered to alert the driver when the vehicle begins to drift over the markings. Also in 2004, Toyota added a lane keeping assist feature to the Crown Majesta, which can apply a small counter-steering force to aid in keeping the vehicle in its lane. 2005. Citroën became the first in Europe to offer LDWS on its 2005 C4 and C5 models, and its C6. This system uses infrared sensors to monitor lane markings on the road surface, and a vibration mechanism in the seat alerts the driver of deviations. 2006. Lexus introduced a multi-mode lane-keeping assist system on the LS460, which utilizes stereo cameras and more sophisticated object and pattern recognition processors. This system can issue an audio-visual warning and also, using the electric power steering or EPS, steer the vehicle to hold its lane. It also applies countersteering torque to help ensure the driver does not overcorrect or soar the steering wheel while attempting to return the vehicle to its proper lane. If the radar cruise control system is engaged, the lane keep function works to help reduce the driver's steering input burden by providing steering torque. However, the driver must remain active or the system will deactivate. 2007. In 2007, Audi began offering its Audi Lane Assist feature for the first time on the Q7. This system, unlike the Japanese assist systems, will not intervene in actual driving. Rather, it will vibrate the steering wheel if the vehicle appears to be exiting its lane. The LDW system in Audi is based on a forward-looking video camera in its visible range, instead of the downward-looking infrared sensors in the Citroën. Also in 2007, Infiniti offered a newer version of its 2004 system, which it called the Lane Departure Prevention (LDP) system. This feature utilizes the vehicle stability control system to help assist the driver maintain lane position by applying gentle brake pressure on the appropriate wheels. 2008. General Motors introduced lane departure warning on its 2008 model year Cadillac STS, DTS and Buick Lucerne models. The General Motors system warns the driver with an audible tone and a warning indicator on the dashboard. BMW also introduced lane departure warning on the 5 Series and 6 Series, using a vibrating steering wheel to warn the driver of unintended departures. In late 2013, BMW updated the system with Traffic Jam Assistant appearing first on the redesigned X5. This system works below 25 miles per hour. Volvo introduced the lane departure warning system and the driver alert control on its 2008 model year S80, the V70 and XC70 executive cars. Volvo's lane departure warning system uses a camera to track road markings and sound an alarm when drivers depart the lane without signaling. The systems used by BMW, Volvo and General Motors are based on core technology from Mobileye. 2009. Mercedes-Benz began offering a lane-keeping assist function on the new E-Class. This system warns the driver, with a steering wheel vibration, if it appears the vehicle is beginning to leave its lane. Another feature will automatically deactivate and reactivate if it ascertains the driver is intentionally leaving his lane, for instance, aggressively cornering. A newer version will use the braking system to assist in maintaining the vehicle's lane. 2010. Kia Motors offered the 2011 Cadenza premium sedan with an optional lane departure warning system, LDWS. In limited markets, this system uses a flashing dashboard icon and emits an audible warning when a white lane marking is being crossed, and emits a louder audible warning when a yellow line marking is crossed. This system is cancelled when a turn signal is operating, or by pressing a deactivation switch on the dashboard. It works by using an optical sensor on both sides of the car. 2013. Mercedes began Distronic Plus with steering assist and stop-and-go pilot on the redesigned S-Class in 2013. 2014. Tesla Model S comes with advanced lane assistance systems with their 2014 release. It was also released with a speed assist feature where the front-facing camera reads and traffic speed limits using the technology of computer vision character recognition system, and then conveys it to the car. On roads where traffic signs are absent, it relies on the GPS data. When the car moves away from a lane at above 30 miles per hour, the system beeps and the steering wheel vibrate, alerting the driver of an unintended lane change. This happens during speed limit non-compliance as well. Fiat is also launching its Lane Keep Assist feature based on TRW's Lane Keeping Assist system, also known as the Haptic Lane Feedback System. This system integrates the lane detection camera with TRW's electric power steering system. When an unintended lane departure is detected, the turn signal is not engaged to indicate the driver's desire to change lanes. The electric power steering system will introduce a gentle torque that will help guide the driver back toward the center of the lane. Introduced on the Lancia Delta in 2008, this system earned the Italian Automotive Technical Association's Best Automotive Innovation of the Year award for 2008. Peugeot introduced the same system as Citroën in its new 308. Lane departure warning systems combine prevention with risk reports in the transportation industry. VUNOC supplies video-based technology to assist fleets in lowering their driving liability costs by providing safety managers with driver and fleet risk assessment reports and tools. It facilitates proactive coaching and training to eliminate high-risk behaviors. The Lookout solution is used by North American fleets, and there is research on implementing a lane departure warning system via a mobile phone. Lane keeping. Lane keeping assist is a feature that, in addition to the lane departure warning system, automatically takes steps to ensure the vehicle stays in its lane. Some vehicles combine adaptive cruise control with lane keeping systems to provide additional safety. While the combination of these features creates a semi-autonomous vehicle, most require the driver to remain in control of the vehicle while it is in use. This is because of the limitations associated with the lane keeping feature. The lane keeping assist system are being achieved in modern driverless vehicle systems using image processing techniques called HERF transform and canny edge detection techniques. These advanced image processing techniques derive lane data from forward-facing cameras attached to the front of the vehicle. Real-time image processing using powerful computers like NVIDIA's Drive PX1 are being used by many vehicle OEMs to achieve fully autonomous vehicles in which lane detection algorithm plays a key part. Advanced lane detection algorithms are also being developed using deep learning and neural network techniques. NVIDIA has achieved high accuracy in developing self-driving features including lane keeping using the neural network-based training mechanism in which they use a front-facing camera in a car and run it through a route and then uses the steering input and camera images of the road fed into the neural network and make it learn. The neural network then will be able to change the steering angle based on the lane change on the road and keep the car in the middle of the lane. Tesla uses the most advanced lane assist system combined with their adaptive cruise control system, marketed together as Autopilot. It includes features like lane keeping assist and also automatic lane changing without driver input. A similar technology to lane assist is used to do auto park feature as well. A lane keeping assist mechanism can either reactively turn a vehicle back into the lane if it starts to lever proactively keep the vehicle in the center of the lane. Vehicle companies often use the term lane keeping assist to refer to both reactive lane keep assist (LKA) and proactive lane centering assist (LCA). But the terms are beginning to be differentiated. Vehicles requires driver control while vehicle is in use, but adjusts steering if vehicle detects itself drifting out of lane. List shows up to 2015 model year. This feature became more widespread since allows unassisted driving under limited conditions. Limitations: lane departure warning systems and lane keeping systems rely on visible lane markings. They typically cannot decipher faded, missing, or incorrect lane markings. Markings covered in snow or old lane markings left visible can hinder the ability of the system. See also: autonomous car, pre-crash system, adaptive cruise control, blind spot monitor, intelligent car, advanced front lighting, swiveling headlamps, lane